Peat is an accumulation of partially decayed vegetation or organic matter that is unique to natural areas called peatlands or mires. The peatlands ecosystem is the most efficient carbon sink on the planet because peatland plants capture the CO2 which is naturally released from the peat, thus maintaining an equilibrium. In natural peatlands, the annual rate of biomass production is greater than the rate of decomposition, but it takes thousands of years for peatlands to develop the deposits of 1.5 to 2.3 meters, which is the average depth of the boreal peatlands. One of the most common components is sphagnum moss, although many other plants can contribute. Soils that contain mostly peat are known as histosols. Peat forms in wetland conditions, where flooding obstructs flows of oxygen from the atmosphere, slowing rates of decomposition. Peatlands, also known as mires, particularly bogs, are the most important source of peat, but other less common wetland types also deposit peat, including fens, pocozones, and peat swamp forests. Other words for lands dominated by peat include moors or mesquites. Landscapes covered in peat also have specific kinds of plants, particularly sphagnum moss, ericaceous shrubs, and sedges. Since organic matter accumulates over thousands of years, peat deposits also provide records of past vegetation and climate stored in plant remains, particularly pollen. Hence, they allow humans to reconstruct past environments and changes in human land use. Peat is harvested as an important source of fuel in certain parts of the world. By volume, about 4 trillion m3 of peat are in the world, covering a total of around 2% of global land area, containing about 8 billion terajoules of energy. Over time, the formation of peat is often the first step in the geological formation of other fossil fuels such as coal, particularly low-grade coal such as lignite. Depending on the agency, peat is not generally regarded as a renewable source of energy, as its extraction rate in industrialized countries far exceeds its slow regrowth rate of 1 mm per year, and as peat regrowth is also reported to take place in only 30 to 40% of peatlands. Because of this, the United Nations Framework Convention on Climate Change, and another organization affiliated with the United Nations classifies peat as a fossil fuel. However, the Intergovernmental Panel on Climate Change has begun to classify peat as a slow renewable fuel. This is also the classification used by many in the peat industry. At 106 grams CO2 mg, the carbon dioxide emission intensity of peat is higher than that of coal and natural gas. Peat fires have been responsible for some large public health disasters, including the 1997 Southeast Asian haze. Peatlands distribution. In a widely cited article, Wojsyl and Clark define peatlands, or mires, the most widespread of all wetland types in the world, representing 50 to 70% of global wetlands. They cover over 4 million km, 2 or 3% of the land and freshwater surface of the planet. In these ecosystems are found 1/3 of the world's soil carbon and 10% of global freshwater resources. These ecosystems are characterized by the unique ability to accumulate and store dead organic matter from sphagnum and many other non-moss species, as peat, under conditions of almost permanent water saturation. Peatlands are adapted to the extreme conditions of high water and low oxygen content, of toxic elements and low availability of plant nutrients. Their water chemistry varies from alkaline to acidic. Peatlands occur on all continents, from the tropical to boreal and Arctic zones, from sea level to high alpine conditions. Wojsyl and Clark 2002. Peatlands are areas of land with a naturally accumulated layer of peat. Peatlands are found in at least 175 countries and cover around 4 million km², or 3% of the world's land area. In Europe, peatlands extend to about 515,000 square kilometers. Peat deposits are found in many places around the world, including Northern Europe and North America, principally in Canada and the northern United States. Some of the world's largest peatlands include the West Siberian lowland, the Hudson Bay lowland, and the Mackenzie River Valley. The amount of peat is smaller in the southern hemisphere, partly because there is less land. Yet South America has one of the world's largest wetlands, the vast Magellanic moorland, with extensive peat-dominated landscapes. Peat can be found in New Zealand, Kerguelen, and the Falkland Islands, Indonesia, Raja Jaya, and Sumatra. Indonesia has more tropical peatland and mangrove forests than any other nation on Earth. But Indonesia is losing wetlands by 100,000 hectares per year. About 60% of the world's wetlands are peat. About 7% of total peatlands have been exploited for agriculture and forestry. Under proper conditions, peat will turn into lignite coal over geologic periods of time. Formation. Peat forms when plant material, usually in wet areas, is inhibited from decaying fully by acidic and anaerobic conditions. It is composed mainly of wetland vegetation, principally bog plants including mosses, sedges, and shrubs. As it accumulates, the peat can hold water, thereby slowly creating wetter conditions, and allowing the area of wetland to expand. Peatland features can include ponds, ridges, and raised bogs. Most modern peat bogs formed in high latitudes after the retreat of the glaciers at the end of the last ice age some 12,000 years ago. Peat usually accumulates slowly, at the rate of about a millimeter per year. Peat in the world's peatlands is currently believed to have been forming for 360 million years and contains 550 gt of carbon. Types of peat material. Peat material is either fibrook, hemic, or cypress. Fibrook peats are the least decomposed, and comprise intact fiber. Hemic peats are somewhat decomposed, and cypress are the most decomposed. Phragmites peat is one composed of red grass, Phragmites australis, and other grasses. It is denser than many other types of peat. Engineers may describe a soil as peat which has a relatively high percentage of organic material. This soil is problematic because it exhibits poor consolidation properties, characteristics and uses. Peat is soft and easily compressed. Under pressure, water in the peat is forced out. Upon drying, peat can be used as fuel. It has industrial importance as a fuel in some countries, such as Ireland and Finland, where it is harvested on an industrial scale. In many countries, including Ireland and Scotland, where trees are often scarce, peat is traditionally used for cooking and domestic heating. Stacks of drying peat dug from the bogs can still be seen in some rural areas. Peat's insulating properties make it of use to industry. Although peat has many uses for humans, it also presents severe problems at times. Wet or dry, it can be a major fire hazard, as peat fires can burn almost indefinitely. Peat fires can even burn underground, reigniting after the winter, provided a source of oxygen is present. Peat deposits also pose major difficulties to builders of structures, roads, and railways, as they are highly compressible under even small loads. When the West Highland Line was built across Rannoch Moor, in western Scotland, its builders had to float the tracks on a mattress of tree roots, brushwood, and thousands of tons of earth and ashes. Peat bogs had considerable ritual significance to Bronze Age and Iron Age peoples, who considered them to be home to nature gods or spirits. The bodies of the victims of ritual sacrifices have been found in a number of locations in Scotland, England, Ireland, and especially northern Germany and Denmark, almost perfectly preserved by the tarning properties of the acidic water. Peat wetlands formerly had a degree of metallurgical importance, as well. During the Dark Ages, peat bogs were the primary source of bog iron, used to create the swords and armor of the Vikings. Many peat swamps along the coast of Malaysia serve as a natural means of flood mitigation. The peat swamps serve like a natural form of water catchment whereby any overflow will be absorbed by the peat. However, this is effective only if the forest is still present, since they prevent peat fires. In Scotland, some Scotch whisky distilleries, such as those on Islay, use peat fires to dry malted barley. The drying process takes about 30 hours. This gives the whiskies a distinctive smoky flavor, often called peatiness. The peatiness, or degree of peat flavor, of a whiskey is calculated in ppm of phenol. The normal Highland whiskies have a peat level of up to 30 ppm, and the whiskies on Islay usually have up to 50 ppm. In rare types, like the Octomore, the whiskey can have more than 100 ppm of peat. In Ireland, large-scale domestic and industrial peat usage is widespread. In the Republic of Ireland, a state-owned company called Bord na Móna is responsible for managing peat production. It produces milled peat which is used in power stations. It sells processed peat fuel in the form of peat briquettes which are used for domestic heating. These are oblong bars of densely compressed, dried, and shredded peat. Peat moss is a manufactured product for use in garden cultivation. Turf is very commonly used in rural areas. In Northern Ireland there is small-scale domestic turf cutting in rural areas, but areas of boglands have been diminished because of changes in agriculture. Afforestation has seen the establishment of tentative steps towards conservation, such as at Peatlands Park, County Armagh, which is an area of special scientific interest. In England, the extraction of peat from the Somerset levels is known to have taken place during Roman times, and has been carried out since the levels were first drained. On Dartmoor there were several commercial distillation plants formed and run by the British Patent Naphtha Company in 1844. These produce naphtha on a commercial scale from the high-quality local peat. Fens, Wixall and Betisfield mosses are elements of a post-Ice Age peat bog that straddles the England-Wales border, only lightly hand-dug. It is now a national nature reserve which is being restored to natural condition and contains many rare plant and animal species due to the acidic environment created by the peat. In Finland, the climate, geography and environment of Finland favor bog and peat bog formation. Peat is available in considerable quantities. Some estimates put the amount of peat in Finland alone to be twice the size of the North Sea oil reserves. This abundant resource is burned to produce heat and electricity. Peat provides around 6.2% of Finland's annual energy production, second only to Ireland. The contribution of peat to greenhouse gas emissions of Finland can exceed a yearly amount of 10 million tons carbon dioxide, equal to the total emissions of all passenger car traffic in Finland. Finland classifies peat as a slowly renewing biomass fuel, and that position has also been taken by the European Union. The Intergovernmental Panel on Climate Change has taken the position that peat is not a fossil fuel. Peat producers in Finland often claim that peat is a special form of biofuel because of the relatively fast retake rate of released CO2 if the bog is not forested for the following 100 years. Also, agricultural and forestry-drained peat bogs actively release more CO2 annually than is released in peat energy production in Finland. The average regrowth rate of a single peat bog, however, is indeed slow, from 1,000 up to 5,000 years. Furthermore, it is a common practice to forest used peat bogs instead of giving them a chance to renew, leading to lower levels of CO2 storage than the original peat bog. At 106 grams CO2 mj, the carbon dioxide emissions of peat are higher than those of coal and natural gas. According to one study, increasing the average amount of wood in the fuel mixture from the current 2.6% to 12.5% would take the emissions down to 93 grams CO2 mj, though little effort is being made to achieve this. Peat extraction is also seen by some conservationists as the main threat to biodiversity in Finland. The International Mire Conservation Group in 2006 urged the local and national governments of Finland to protect and conserve the remaining pristine peatland ecosystems. This includes the cessation of drainage and peat extraction in intact mire sites and the abandoning of current and planned groundwater extraction that may affect these sites. A proposal for a Finnish peatland management strategy was presented to the government in 2011, after a lengthy consultation phase. In Russia, use of peat for energy production was prominent during the Soviet Union, with the peak occurring in 1965 and declining from that point. In 1929, over 40% of the Soviet Union's electric energy came from peat, which dropped to 1% by 1980. In the 1960s, larger sections of swamps and bogs in western Russia were drained for agricultural use and to generate peat fields for mining. Plans are underway to increase peat output and increase peat's contribution to Russian energy generation. However, there is concern about the environmental impact as peat fields are flammable, drainage degrades ecosystems, and burning of peat releases carbon dioxide. The initial costs for the program are estimated to be about 20 to 25 billion rubles, which is close to 500 million euros. Currently, Russia is responsible for 17% of the world's peat production, and 20% of the peat that it produces, 1.5 million tons, is used for energy purposes. Shatra Power Station in Moscow Oblast and Kirov Power Station in Kirov Oblast are the two largest peat power stations in the world. Used in agriculture in Sweden, farmers use dried peat to absorb excrement from cattle that are wintered indoors. The most important property of peat is retaining moisture in container soil when it is dry and yet preventing the excess of water from killing roots. When it is wet, peat can store nutrients. Although it is not fertile itself, it is a polyelectrolytic with a high ion exchange capacity due to its oxidized lignin. Peat is discouraged as a soil amendment by the Royal Botanic Gardens, Kew, England, and has been since 2003. While bark-based peat-free potting soil mixes are on the rise, particularly in the UK, peat remains an important raw material in horticulture in Canada, as well as parts of the United States. However, it is recommended to treat peat thermally, e.g., through soil steaming, in order to kill inherent pests and reactivate nutrients. Freshwater aquaria. Peat is sometimes used in freshwater aquaria, most commonly in softwater or blackwater river systems, such as those mimicking the Amazon River basin. In addition to being soft in texture and therefore suitable for demersal species such as corridoras catfish, peat is reported to have a number of other beneficial functions in freshwater aquaria. It softens water by acting as an ion exchanger. It also contains substances that are beneficial for plants and for the reproductive health of fishes. It can even prevent algae growth and kill microorganisms. Peat often stains the water yellow or brown due to the leaching of tannins. Water filtration. Peat is used in water filtration, such as for the treatment of septic tank effluent, as well as for urban runoff. Due to its purifying properties, peat also serves as a filter for septic tanks and may be used as a water purifier. Balneotherapy. Peat is widely used in balneotherapy. Many traditional spa treatments include peat as part of peloids. Such health treatments have a very long tradition in Europe, especially in Poland, the Czech Republic, Germany and Austria. Some of these old spas go back to the 18th century, and they are still active today. The most common types of peat application in balneotherapy are peat muds, poultices, and suspension baths. Peat archives. Authors Ryden and Jeglum in Biology of Habitats describe the concept of peat archives, a phrase coined by influential peatland scientist Harry Godwin in 1981. In a peat profile there is a fossilized record of changes over time in the vegetation, pollen, spores, animals, and archaeological remains that have been deposited in place, as well as pollen, spores and particles brought in by wind and weather. These remains are collectively termed the Peat Archives. Ryden 2013, in Quaternary Paleoecology, first published in 1980. Burks and Burks described how paleoecological studies of peat can be used to reveal what plant communities were present, what time period each community occupied, how environmental conditions changed, and how environment affected the ecosystem in that time and place. Scientists continue to compare modern mercury accumulation rates in bogs with historical natural archives records in peat bogs and lake sediments to estimate the potential human impacts on the biogeochemical cycle of mercury. For example, over the years different dating models and technologies for measuring date sediments and peat profiles accumulated over the last 100 to 150 years have been used, including the widely used vertical distribution of 210 petabits, the ICP-SMS, and more recently the initial penetration